the rational equation is x over 2 minus x over 3 equals 12. We call it rational because we have x over 2, x over 3, some function over another function makes it rational. Before we can solve, we need to find the least common denominator. The denominator that is common to both 2 as well as 3. If you cannot come up with a common factor, here 2 and 3, they have nothing in common. The least common denominator is simply 2 times 3, which will give us 6. So to make the first fraction have a denominator of 6, I'm going to multiply and divide x over 2 by 3. The second fraction, multiply and divide by 2, or rational expression. And that would equal to 12. Now, 3 times x is 3x divided by 6. 2 times x is 2x. We'll have divided by 6 equal to 12. Now you can see that we have a common denominator. So the common denominator is 6. Since we have a common denominator, we can combine the numerators. 3x minus 2x over 6 would equal 12, which would mean x over 6 equals 12. We multiply both sides by 6 to solve for x. So x would be equal to 6 times 12, which is 72. So here is another rational equation, and we want to solve for x. This might look like a different equation compared to the previous problem, but it is no different. All I have to do, just like we do always when solving equations, move all terms that contain x to one side, numbers to the other. So I will have x over 3, move x over 4 to the other side, to the left-hand side, we'll have negative x over 4 equals 1 over 6. I'm looking for a common denominator between 3 and 4. There isn't one, so the common denominator is 12. So I multiply and divide the first rational expression by 4. I multiply and divide the second rational expression by 3. So we will have 4x over 12 minus 3x over 12 equals 1 over 6. Since I have a common denominator of 12, I can combine the numerators and write it as 4x minus 3x. And that would equal to 1 over 6. So 4x minus 3x is simply x over 12, which would equal to 1 over 6. If I multiply by 12 on both sides, I could solve for x. So x would be 12 over 6, which would mean x is 2. So since we are solving for x, we have to move all the x terms to one side. So x over 2 plus x over 5 would be equal to 21 over 10. I need a common denominator between 2 and 5. There isn't one, so the least common denominator is 10. I multiply and divide the first expression, x over 2 by 5. I multiply and divide the second expression by 2 so that I get a common denominator of 10. This would mean 5x over 10 plus 2x over 10 would be equal to 21 over 10. Since I have a common denominator, I can add the numerators. 5x plus 2x equals 21 over 10. The 10s will get cancelled. 7x would be equal to 21, which would mean x is 21 over 7, you get 3. So here is an interesting case. Suppose we have x squared plus 1 over x equals 5 over x. So since we only have a rational expression by itself here, rational expression by itself there, we can rewrite the equation as x squared plus 1. After we cancel out the x squared plus 1 equals 5. This would mean x squared would be equal to 5 minus 1. X squared would be equal to 4. X is plus or minus 2. So if we have individual rational expressions, then we can simplify directly on either side. And the problem is quite straightforward. The issue comes when we have different denominators. That's where we need to find the least common denominator and make the denominators identical before we proceed. A good example for that case is 5 over x minus 2 minus 2 over x plus 4 equals negative 4 divided by x squared plus 2x minus 8. So a few things to note. Of course, we have to find the least common denominator. And we look at x squared plus 2x minus 8. Now that is a second order polynomial. So when you see an expression of that sort, the first question to ask would be, could I factor that? So we will get to that part soon, or we can do it right now. So the factors of x squared plus 2x minus 8 are x minus 2 and x plus 4. In a problem like this, they have made it easier, but this is not always the case. You can see the factors on the other side. Now we want to make the denominators identical on the left-hand side. There is nothing in common between x minus 2 and x plus 4. So the least common denominator is x minus 2 times x plus 4. So I multiply and divide the first rational expression by x plus 4. Multiply and divide the second rational expression by x minus 2. This way, I would have a common denominator of x plus 4 times x minus 2. Since I have a common denominator, I can combine the numerators. So x plus 4 times 5 minus 2 times x minus 2 equals negative 4 over x minus 2, x plus 4. Like we did in the previous problems, we have an individual rational expression on the left-hand side, individual rational expression on the right-hand side. I can directly cancel the denominators. So those two would go away. So we will have -4 on the right-hand side. Distribute the 5 and -2, here and there. So 5 times x is 5x. 5 times 4 is 20. -2 times x is -2x. -2 times -2 is +4. So 5x minus 3x, 2x is 3x. 20 plus 4 is 24. And that would equal -4. So 3x would then be equal to -4. Move the 24 to the other side. We will have -24. 3x would be equal to -28, which would mean x is -28 divided by 3. So we'd like to solve for x, and the right-hand side, the denominator, has a second-degree polynomial, which is x squared minus 1. And that is of the form a squared minus b squared. So I can write it as x plus 1 times x minus 1. On the left-hand side, we don't have anything in common between the denominators. So the least common denominator is x minus 1 times x plus 1. To get the least common denominator, I multiply the first expression by x plus 1 and divide by x plus 1. The second expression, I multiply and divide by x minus 1. This way, I've got a common denominator of x plus 1 times x minus 1. So the common denominator is x plus 1 times x minus 1. Since we have that in common, we can combine the numerators. So x plus 1 times 1, which would simply be x plus 1. 1 times x minus 1 is x minus 1. And that would equal to 2 over x plus 1 times x minus 1. The denominators will get cancelled because we have a rational expression by itself on either side. In the numerator, on the left-hand side, the 1 and the -1 will get cancelled. X plus x would be 2x is equal to 2. So if we divide by 2 on both sides, we will have x to be equal to 1.